Hi guys, this is Lisa Knight. Today you're going to be doing the BallTossLab. So to find the file that you need, you want to open up Logger Pro and you want to go to Open and you want to go to File Open. And once you do that, you want to go into the Sample Movies folder. Go find the Sample Movies folder, and in the Sample Movies folder, you're going to find the folder called BallToss. And in that, you should have a Logger profile and a video. And when you click on that Logger profile, you'll get a video, you'll get a replay screen, and you'll get two blank graphs. One will be a position time graph, and one will be a velocity time graph. If you don't see the replay window, then you want to go to Analyze and click on Replay, and that'll pop this up. If you don't see the video, that means that the video is missing. So you need to find the video, and that's usually in the extensions within your Logger Pro files on your computer. If not, if you can't find that video and insert it inside Logger Pro, then just email me and I can send it to you. So all you do is you just click on the Start button on the Replay button, and there's your data. It's pretty simple. And then you're going to click on the Analyze button, which is the button with the graph with the red line through it. And as you scroll across the graphs, you can see the motion of the ball. So what you're going to do is you're going to be calculating the potential energy, the kinetic energy, and then you're going to add them together to find the total energy of the ball at 3 different points. You want to find 1 point in the trajectory when it's left her hands, 1 point when it's at the top of its path, and 1 point right before it goes back to her hands. So, and then you're going to calculate and look at how the potential energy and the kinetic energy change as the ball rises and falls. And according to conservation of energy, when you add those together, although they are individually changing, the total mechanical energy should stay the same, as long as there's nothing else acting on the ball other than gravity. So in this particular scenario, we really want to be careful finding those points. So remember that if you look at your velocity graph here, the highest velocity is going to be where it's going to occur when she throws the ball up and she releases the ball. The zero velocity is going to be close to the top when it comes to a stop instantaneously. And then the most negative velocity, downward velocity, is going to be right before she catches it. So you want to make sure by looking at the video that you're getting a point where she truly is not touching the ball. Near the top, near the release, near the top, and near the catch. Once you have done that, you will have the position and the velocity for each of those points, and you will calculate the potential energy and the velocity of the ball. And then you can make a graph of the potential energy for each point, and then a graph of the kinetic energy for each point, and you should see one going up and down and one going down and up, right? They should be the reverse of each other. And then you're going to do the total energy, and you may have to play with the scale of the total energy on the y-axis so that it'll look flat. If the scale is too small, if you let Logger Pro do the scale, it's just going to figure out a scale based on the range of numbers that you have. And if you have numbers that are really close to each other in value, then you're going to have a scale that's going to go from, 1.5 to 1.6. And what's going to happen is that's such a small scale that you're really going to see a jagged look. The points are going to artificially look far apart from each other and not look flat. So if you change a scale on the y-axis to -3 to 3, then those points of 1.5, 1.6, and 1.4 5'9", are not going to look far apart from each other. They're going to look very tightly grouped in the Y direction because the scale is bigger. And it'll look flat. So the total energy graph should be a flat line, right? Because it should be staying constant unless there's an outside force. And in this case, air drag is not the outside force. Okay, air drag is not significantly a factor because that ball is only in the air for a second. It's in the air, the toss is 0.5 seconds to less than 1.5 seconds. So air drag is not a big factor in this lab. However, her hands are a big factor. So if you get values where her hands are definitely touching the ball, you're going to see some big differences in the total energy at those points. So pay attention to what you're doing, and you're just kind of verifying the law of conservation of energy in this lab.